Right, it's 10 o'clock, Saturday, 7th of September, 2024. Welcome to this live stream of Brainshift Tutoring. I hope you guys are going to have a lovely time here, and I hope that you're going to enjoy all of the content that we're going to offer. My name is Jeremy Brown, and I'm the Managing Director of Brainshift, and I'm going to be your instructor for the duration of this course. Please grab a pen and paper, sit back, enjoy, grab a cup of coffee, cup of tea, cup of Coke, well, whichever you prefer. Get comfortable, sit down and relax. Get your pen and paper ready. Let's work together on differential calculus, shall we? And so, this is the content that we'll be covering today. We'll be looking at a basic introduction of what differential calculus is. What's the big thing about it? Why do we need to use it? And what are these derivatives that we keep on hearing about? We're also going to look at what the limit is. So for those of you who are doing the IEB syllabus, limits are actually assessed in your exams. For CAPS learners, limits are not such a big thing, but it would be very good for you to know about them and how we actually get to use them. We're going to have a look at the gradient and average gradient. Gradient is something that you've been working with ever since, I don't know, early high school days. And then we talk about the average gradient, and because this is average gradient, we are referring to a curve. Now, some of you actually did this in grade 11, where they give you, let's say, a parabola, or a hyperbola for that matter. And they ask you to calculate the average gradient. So that's what we're going to be having a look at. It's basically going to be a revision of what you did in grade 11. We'll have a look at the derivative, what the derivative is, why we need to use it, how we actually get to use it. Then we'll go through the rules or the laws of differentiation. Now, I know you've probably seen a list of these in your textbook and you're asking yourself, why is all of this there? What is it all meant for? That's what we'll have a look at. We'll also look at finding the equation of the tangent. If you're not sure what a tangent is, no worries, sit back and relax, we'll actually discuss this. Then a big portion of today's session will actually be on the cubic function. We're going to be discussing what the cubic function is. We're going to be having a look at how to find the x-intercepts, how to find the y-intercept, how to find the stationary points, the point of inflection, and then last but not least, we'll have a look at the application of calculus, basically optimization and rate of change. I hope you guys are excited for it. I know some of you wrote your exams quite recently and maybe things went excellent, maybe things did not go so well for you, but this will definitely assist you in preparing for your final exams and in general just getting to understand differential calculus a lot better. Without any further ado, let's get straight into it. Now, we've got calculus, or to be specific, yes, we've got calculus. Now, calculus is the study of problem solving involving the rates of change. Now, think about this, for example. Here's a scenario. You wake up every morning and, well, the sun is on its way up. Hopefully, you're not one of those people that woke up and the sun is already up, right? Well, hopefully you're one of those people who wake up nice and early to be nice and refreshed. But now you notice that as the sun makes its way across the sky, something is happening to the temperature. There's an increase in temperature, be it in summer, be it in winter. There's an overall increase in temperature. Now the question would be, how fast does the temperature change as the time changes? Or how fast does the temperature change as the position of the sun in the sky changes? Another scenario. Think about this, for example. A typical scenario would be you've got a burst water pipe and water is flowing out of that pipe. At what rate is water moving out of the pipe? How fast is the water moving? What would be the maximum water at a specific time interval? That's what we mean by rates of change. Now, just as a matter of interest, calculus was invented by Sir Isaac Newton. Yes, for those of you doing physical science, you know who I'm referring to. Same guy that gave you those many laws of gravity and acceleration and all of those type of things. He also invented calculus. Must have been a very intelligent guy. Nevertheless, we've got two main branches of calculus. You've got differential calculus, and you also have integral calculus. Now, what is the difference between the two? We've got differential calculus being used to solve the problem of the rates of change. In other words, we use differential calculus to determine the gradient of the tangent at a specific point. We use differential calculus to do the problem solving involving rates of change. I hope that that makes sense. Now, when we are looking at integral calculus is what we use to determine the volume and surface area of 3D objects. Now, basically, what are we saying? This is something that you will do at a university level should you consider to go into computer science or engineering or any of those hectic fields. Even physics, you actually get to understand this. We're basically saying that if we have a 3D shape, how can we determine the volume of the 3D shape? Let me give you an example. So say we have a little sketch here of a parabola. If I take this parabola and I rotate it about the y-axis, what you will notice is that I get some sort of a 3D shape, some sort of a 3D cup, if I can put it that way, or 3D oval. What do we use this for? Well, basically with integral calculus, we can say, do we have a formula to determine the volume inside of this cup? Can we use a formula to determine the surface area inside of this cup or inside of the shape? Now notice with primitive shapes like your cylinders, your cones, your spheres, and your prisms and pyramids, you have predefined formulas. So there's a list of formulas that you're supposed to know off by heart. We'll actually look at this in the very last section when we talk about optimization and rate of change. But with other not so primitive shapes, you do not have the luxury of having a list of formulas at your disposal. Does that mean that some shapes do not have a formula for volume or surface area? Think about this, for example. Think about the vase in your living room. Or think about the cup that you're drinking your tea out of. Is it a perfect cylinder? If it's not a perfect cylinder, how would we calculate the volume of whatever is inside of that specific cup? Well, that's what integral calculus is all about. Fortunately for you, or should I say unfortunately for you, integral calculus is not assessed in high school. In high school, you're only doing differential calculus, the gradient of the tangent. Integral calculus, as I've mentioned before, it's for those of you who will go into depth in calculus, should you decide to consider studying computer science or engineering. So, as I've mentioned, integral calculus is not in a grade 12 syllabus, so we don't have to worry about the complexities and intricacies of having to calculate the volume of 3D surfaces. Now, let's get into something interesting, the concept of a limit. Now, we've got a function here, f of x equals to x squared minus 16 divided by x minus 4. This specific example, we might want to be interested in knowing what happens as x gets closer to 4. Take note that f of 4 is undefined. What does that mean? It simply means that if I substitute x is equals to 4 into my equation, for my denominator, I'm going to have 4 minus 4, which is going to give me 0. You've learned before that division by 0 is undefined. Hence, we are saying that we want to be interested in, what happens as we get closer and closer to x is equals to 4. Not necessarily what happens at x is equals to 4, because we know we've got an undefined value. So, how do we determine, or how do we calculate what happens closer to x equals to 4? Basically, what you will notice is that your numerator is a difference of 2 squares. When factorizing this difference of 2 squares, we will get x minus 4 into x plus 4 divided by x minus 4. Now the x minus 4 and the x minus 4 will cancel out, leaving you with x plus 4. Now when we get to this point, we can actually substitute the value of x as 4. Then we get 4 plus 4 equals to 8. So basically what we're saying is, as x gets closer and closer to positive 4, y gets closer and closer to 8. This is the concept of the limit. I hope that this makes sense. Now notice that we had to factorize the expression before we could substitute x is equals to 4, because had we substituted x is equals to 4, we were going to get undefined. This does not necessarily mean that you always have to factorize. There are cases in which it is possible to factorize, but you still get a division by 0. In such an instance, the limit does not exist. I hope that that makes sense. Right, let's have a formal definition of what the limit is. The limit, we're saying the limit of a function is the value that y approaches as x approaches a certain value. So in other words, if we say, for example, the limit as x approaches 4, let's say we've got just 2x minus 6 here. We are saying, what is the y value that this function approaches as x gets closer and closer to 4? I hope that this makes sense. So, as I've mentioned earlier, when we are calculating limits, we can either use direct substitution, as we did in the previous example here, where we just substituted right at the final step. Sometimes direct substitution will give us division by 0. So what we need to do then is we could do our factorization. We factorize as far as possible, then substitute. If after factorization we still get undefined, the limit does not exist. Right, enough talking. Let's actually look at a couple of examples. And here's our first example. We're supposed to calculate the limit as x approaches 3 of 2 over x plus 2. To solve this, let's actually go to the whiteboard and let's copy down this question. So we've got the limit as x approaches 3 of 2 over x plus 2. Now to calculate the limit, let's ask ourselves this question. Can we substitute x is equals to 3 and not get undefined? Well, let's check. First of all, if I substitute x is equals to 3 into my denominator, I get 3 plus 2, which is equals to 5. This does not give me undefined. So it is safe for me to substitute x is equals to 3. Now please take note that when we do our substitution, we can safely get rid of the limit sign. This will be 2 over 3 plus 2, which gives us 2 over 5. So in other words, this graph approaches 2 over 5 as x approaches 3. I hope that this makes sense to you guys and that you understand more or less what this concept of limits is all about. Life is great. Let's go back to our notes and let's see. We've got another question. Now we're supposed to calculate the limit as x approaches 1 of x cubed minus 1 all over x minus 1. Once again, let's go back to our writing pad and let's attempt this question. So we have got the limit as x approaches 1 of x cubed minus 1 all over x minus 1. The first thing that you need to take note of here is that when we substitute x is equals to 1, we're going to get 1 minus 1, which gives us 0. We've got a division by 0, so substitution is not working for us here. Let's see if we can try a different approach. If you look at the top here, this is actually a difference of cubes. And if you can remember from grade 10, we can actually factorize the difference of two cubes. Now, since I'm not yet substituting x is equals to 1, I need to keep my limit sign there. So the limit as x approaches 1. Then I'm going to open two brackets. And all of this will be divided by our x minus 1. Now to factorize the difference of two cubes, what we know is because this is a negative sign, in our brackets we're going to have negative, positive, and positive. If you're not sure about how I'm doing this, or if you're not sure how to do the actual factorization, please have a look at my video on factorizing a cubic expression. I've uploaded a video onto the channel. Please have a look at that and you will understand how to factorize the difference of two cubes. So the first thing we do is we need to take the cube root of our first term. Now the cube root of x cubed, that's x. We put it as the first term in our first bracket. Then we need to find the cube root of 1. Now the cube root of 1 is 1. We are done with the first bracket. To get the next three terms, we take our first term and we square it. Now x squared, it's going to give you x squared. To get the second term, we need to multiply the two terms in the first bracket, but ignore the negative sign. So x times 1, that's going to give us just x. To get the last term in our second bracket, we take the first term that we got in our small bracket and we square it. Negative 1 squared gives us 1. Perfect. When you get to this point, you will realize that x minus 1 and x minus 1 will cancel out. This is going to give us the limit as x approaches 1. And you've got x squared plus x plus 1. Now, when we get to this point, we've got no more denominators. It's safe for us to substitute x is equals to 1. So this is going to give us 1 squared plus 1, which is actually going to give us an answer of 3. Brilliant. So in other words, what we're saying here is, we are saying that as x gets closer to 1, this whole function gets closer and closer to positive 3. It approaches positive 3, and hence we say the limit as x approaches 1 of x cubed minus 1 over x minus 1 is 3. Brilliant. Life is great. I hope that this is making sense and that you guys are still understanding the content and what we're doing. Brilliant. Now let's look at the next question. The question says, evaluate the limit as x approaches 1 of 2x minus 1. Now once again, let's go back to the writing pad and let's see how we could do this one. So this is the limit as x approaches 1. This is going to be 2x minus 1. Once again, we need to ask ourselves the question, when I substitute x is equals to 1, do I get undefined? The answer is no. So I can safely say, let me ignore my limit sign, let me do away with it. Then I substitute x is equals to 1. My answer is positive 1. There we are. Life is great. This one was simple and straightforward because there was nothing specific that you had to, get rid of or find the cancel out first through factorization. Brilliant. I hope this concept of limits makes sense to you guys. Let's look at the next section. Now we're talking about the gradient and the average gradient. They taught you in previous grades that the gradient between 2 points can be calculated as the change in y over the change in x. In other words, you can also calculate your gradient as y2 minus y1 divided by x2 minus x1. Now this is good and dandy, but you need to remember that if we have such a setup, this has to be the straight line joining 2 points. Okay, my line is not very straight, but we need to have a straight line that joins the 2 points because the gradient only exists in a straight line. In fact, the gradient is constant on a straight line. Now, you were also taught to calculate the average gradient. And the average gradient happens when we've got a curve. Now, if I've got 2 points on a curve, let's say for argument's sake, this is A and B, I will calculate my gradient using the gradient formula. But if I have, let's say, 2 other points, let's say this is C and this is D, what you will notice is that on a curve, the gradient is not constant between any 2 points. On a straight line, gradient is always constant between 2 different points. But in this specific case, on any type of a curve, be it a parabola, be it a hyperbola, be it even a trig function for that matter, as long as it's a curve, the gradient is not constant. So we can also have a second formula we can use to calculate the gradient where it's f of x plus h minus f of x divided by h. And basically the h would be the distance between the 2 points that we're given. Now let's look at another example here. We're calculating the gradient between x is equals to 3 and x is equals to 7. Now let's go to the writing pad and let's have a look at this one. And please take note that for this specific question, there are 2 different ways of doing it. And I'm going to show you both ways of doing it. So first, let's write down our equation. We've got f of x is equals to negative 3x squared. The points that we're looking at are x is equals to 3 and x is equals to 7. Now the first way you would do this is typically how you would do it with a straight line. So first we need to calculate the y values. Now f of 3 is going to be, let's substitute x is equals to 3 into our original equation so that we can get the corresponding y value, that's 27. Now let's take x is equals to 7 and substitute it. So x is equals to 7. This will give us negative 3 into 7 squared. Now 7 squared, that's going to give you 49. Let's just check 49 times 3. 9 times 3, that's 27, carry the 2. 4 times 3, that's 12. 12 plus 4, that's 14. So we get 147, negative 147, because we're multiplying with a negative number. Cool. Now that we have the x and the y coordinates, we can use our gradient formula where we say y2 minus y1 over x2 minus x1. Cool. Now from here, let's just substitute what we have. I'm going to call this x1, I'm going to call this x2. That means that this is going to be y1 and this is y2. So this is going to be negative 147 minus 27 divided by, for x2, we've got 7 minus 3. Let's see what this is going to give us. So this is going to be negative 147 plus 27 divided by 7 minus 3, that's going to give us 4. And let's see what this will give us. So we've got negative 147 plus 27. This is a 0, 4 plus 2, negative 4 plus 2. That's 2, we bring down the 1. So we get here negative 120 over 4. Of which, if we simplify this, we're going to get negative 30 as our gradient. Brilliant. I hope that makes sense. Now, the second approach that we could take here is, we could use the formula where we say m is equals to f of x plus h minus f of x divided by h. Whoops. Now, in all honesty, this formula is exactly the same as the one that we used previously. The only difference is we first have to calculate h. To get the value of h, I need to calculate the difference between my x values. In other words, I'm going to say 7 minus 3, that's going to give me 4. Now, in my formula, this is going to be f of, for the x value, we will use our smallest x value, which is x is equals to 3. This is f of 3 plus 4 minus f of 3. Now we got the value of h as 4. When we simplify this, this is going to be f of 7 minus f of 3 divided by 4. Now, remember we already calculated f of 7 and we got that as negative 147. Minus f of 3, which we also calculated. We got f of 3 is negative 27. So negative 27 divided by 4. If you look at this carefully, you will see that we have exactly the same thing that we had in one of the steps above. This is still going to give you negative 120 over 4, which will give you negative 30. And there you are. Life is great. We now know how to calculate the average gradient between 2 points on a curve. Once again, remember, average gradient, let me just write it here. So, if you see average gradient, just know that average gradient applies to a curve. In other words, average gradient does not apply to a straight line. Now you might be thinking, wait a second, the formulas are exactly the same. And that's true, the formulas are exactly the same. But just remember that if it's average gradient, if it's for a curve, the gradient will be different depending on which points you are using on the specific curve. If it's a straight line, you can choose any 2 points and your answer will still be the same, irrespective of which points it is that you choose. Awesome. I hope that this makes sense to you guys. Let's move on to the next section. Now we get to discuss the derivative. Whoops, didn't mean to open that. So we've investigated, or we determined how to calculate the gradient of a curve between 2 points. Once again, we said this was the average gradient. Now, from here, we might be interested in finding out what is the gradient of the curve at a single point. Because as I've mentioned to you, the gradient of a curve changes at every single point. Now we might be interested in finding out what is the gradient of the tangent at a specific point, or what is the gradient at that specific point. And to do that, basically what we do is we take our formula for the gradient, the average gradient, But then what we do is we take the limit as x approaches 0. This is supposed to be a 0. And this formula, you're familiar with it? This is your derivative. This is what they call the first principles. We only use this formula when the question says that you need to find the derivative from the first principles. Now, usually in your exam, whether CAPS or IEB, there's going to be a question for about 4 or 5 marks, sometimes 6 marks if they're in a good mood. It's going to ask you to determine the derivative from the first principles. It is vital that you understand how to use this formula and not to make any mistakes as you're working with it. Let's look at a couple of examples. So the first question says we're finding the derivative of f of x equals to 2x squared minus 1 from the first principles. Let's see how we would go about doing this. So we have f of x is equals to 2x squared minus 1. We need to find the derivative from the first principles. My suggestion is always, for the sake of safety, always calculate f of x plus h separately. What does this mean? Well, this means in our equation for f of x, where we see x, we need to substitute it with x plus h. So this is going to give me 2 over x plus h all squared minus 1. Let's simplify this. This is going to be 2 into x plus h into x plus h minus 1. As I simplify this, I'm going to get 2 into, multiply the brackets. This is x squared plus xh plus xh plus h squared minus 1, which is going to give me 2 into x squared plus 2xh plus h squared minus 1. If we multiply this out, we're going to get 2x squared plus 4xh plus 2h squared minus 1. We don't have any like terms, so let's leave it here. Let's write down our formula. So f prime of x is equals to the limit as h approaches 0 of f of x plus h minus f of x divided by h. This is going to give me the limit as h approaches 0. Now at this point, this is where I would usually say practice safe maths. What that means is open up a bracket, then put down f of x plus h. So 2x squared plus 4xh plus 2h squared minus 1 minus, for f of x as well, put it in brackets. We got f of x is 2x squared minus 1. So 2x squared minus 1. And then all of this is going to be divided by h. Now we simplify. This is going to give you the limit as h approaches 0 of 2x squared plus 4xh plus 2h squared minus 1. Now when we multiply in the negative sign, we're going to get minus 2x squared plus 1. If you did not put the brackets, you are going to have a problem right here. All of this divided by h. If you've done everything correctly to this point, if you've practiced safe math to this point, all of the terms that do not have h as a coefficient must cancel out. Check this. We've got 2x squared minus 2x squared that cancels out. We've got negative 1 and positive 1 that cancels out. Because the terms without h as a coefficient actually cancel out, that means that you've done the right thing. Life is great. So this is going to give you the limit as h approaches 0 of 4xh plus 2h squared. And all of this is going to be divided by h. So all of this divided by h. Now, when you get to this point, what you're supposed to do is, you are supposed to take out h as a common factor. So let's do that. So this is going to be equals to the limit as h approaches 0. When we take out h as a common factor, we're going to remain with 4x plus 2h. All of this, my goodness, sorry about that. All of this is going to be divided by h. From here, the h's will cancel out. Please take note that as I am doing all of this, the limit always remains. If you happen to omit the limit sign beforehand, you're going to lose a mark in your exam. Please take note of that. So, this is going to give us the limit as h approaches 0. Our denominator is gone. We can substitute 4x plus 2h. From this point now, we can substitute h is equals to 0. Since I am substituting h is equals to 0, I can get rid of my limit sign. So this is 4x plus 2 into 0, giving you 4x. And there you are. Your life is great all of a sudden because now you know how to use the derivative from the first principles. Awesome. I hope that this makes sense to you guys. What you need to take out of this is the entire process that we are busy with is to get rid of h as a denominator, which is the same thing that we said previously with our section on the limits. We need to get rid of h as a denominator. Once we have gotten rid of h as a denominator, then we can substitute h is equals to 0. We can get our answers. Then life is great. We move on with life. Brilliant. Hope that this makes sense to you guys. Let's go ahead and look at the next question. So the next question says we need to find f prime from the first principles. Now take note that f prime, this is the derivative. Now they say to us f of x is equals to negative 2 over x. Let's have a look at this one because it is quite interesting. Okay, so first of all, let me put all of this on a new sheet of paper. And our equation f of x is equals to negative 2 over x. Once again, the first thing you need to do is to calculate f of x plus h. This is going to be equals to negative 2 over x plus h. What I suggest you do is before substituting into your calculator, before substituting into your equation, before substituting into your formula, let's actually calculate f of x minus h minus f of x before substituting. X plus h. This is going to be for x plus h, we've got negative 2 over x plus h minus, once again practice safe maths, minus 2 over x. This is going to give you negative 2 over x plus h plus 2 over x. Now, when you get to this point, you need to make sure that you've got the same denominator. What you want to do is you want to put all of your numerators under a common denominator. There's two ways of doing this. In fact, there's multiple ways of doing this. I'm going to show you one. So the first thing I'm going to do is let me write down my equation as it is, my first formula as it is. My first expression as it is. Then notice something. The denominator of the second fraction is x. I am going to multiply the first fraction with the denominator of the second fraction divided by the denominator of the second fraction. In essence, I am multiplying by 1. Your question might be, Mr. Brown, why are you multiplying by 1? Is that not the same as not doing anything? Well, yes. Multiplying by 1, you're not doing anything technically speaking. But I will show you why we are doing it this way in just a second. We put plus 2 over x. Then what we do is we look at the denominator of the first fraction. I'm going to multiply my second fraction with the denominator of the first fraction divided by the denominator of the first fraction. Brilliant. Now from here, what do we do? If you remember from primary school, when multiplying fractions, we need to multiply top by top. So 2 times x, that's going to give me 2x, divided by multiply bottom by bottom. I'm going to leave this as x into x plus h. Right. Do not cancel this out, otherwise you're going to go back to what we had in the first place. Now, let's do the same thing with the second fraction. Multiply top by top, that's going to give me 2 into x plus h, divided by multiply bottom by bottom. x into x plus h. Once again, do not cancel this out. You will end up in big trouble. Now coming back to what you were thinking earlier to say, why am I multiplying by 1? Remember I said when we add or subtract fractions, we want to make sure that the denominators are the same. Now notice our denominators are now the same. We've got x into x plus h, we've got x into x plus h. What we can do is we can put our numerators under the same denominator. So negative 2x plus 2, let's multiply out the brackets here, 2x plus 2h. Then all of this is going to be divided by x into x plus h. At this point, negative 2x and positive 2x cancel out. You will remain with 2h over x into x plus h. If you want to, you can multiply out the brackets of the denominator, but I'm just going to leave it like this for the sake of simplicity. Brilliant. Now, let's move on to the next section. Notice that we actually haven't answered the question yet. We were just simplifying f of x plus h minus f of x. Now we can actually simplify the question. So f prime of x is the limit as h approaches 0 of f of x plus h minus f of x, all of this divided by h. Now, we've already calculated what f of x plus h minus f of x is. I'm just going to substitute it in here. So this is going to be 2h over x into x plus h all over h. Now, I don't like the way this is looking. And if you remember from primary school that if we have a setup such as this, what we can do is we could say this is 2h over x into x plus h multiplied by 1 over h. When you do this, your h and your h will cancel out. You no longer have h as a denominator. You can actually go ahead now and substitute. Before we substitute h is equals to 0, let's simplify this. This is going to be the limit as h approaches 0 of 2 over x into x plus h. Now that we have eliminated h as a denominator, we could substitute h is equals to 0. So now this is going to be 2 over, let me fix this, 2 over x into x plus 0. This is going to give us 2 over x times x, which is 2 over x squared. And there we have it. We have calculated our derivative. We have determined our derivative. Awesome. Life is great. I hope that this makes sense to you guys. Now, let's look at the next question. In our next question, okay, there is no next question. Nevertheless, let's move on to the next section, the rules of differentiation or the laws of differentiation. Once again, as I said to you, you've probably seen this in the textbook and you've asked yourself, what the heck does this mean? How am I supposed to use this? Well, basically, this is going to help us in finding the derivative of any expression without using the first principles. Now, as I've mentioned to you, there's going to be one question where they will ask you to determine the equation. Sorry, they'll ask you to find the derivative using the first principles. Then there's going to be a second set where you'll be asked to find derivatives, but it would not be necessary for you to use the first principles. In fact, in some instance, it might not actually be possible to use the first principles to calculate this at your level. Nevertheless, let's have a look at some questions. So before we look at that, the most important rule that you need to know is a shortcut to using the first principles is this. We multiply the exponent by the coefficient, then subtract 1 from the exponent. But if the question says using the first principles, make sure that you use the first principles. Only after, in the next set of questions, would you then use the shortcut that I've shown you just now. Let us look at some questions. So the question says evaluate the following. Now when you see this dx, the dx basically means find the derivative. There's different ways that the question will ask you to find the derivative. It's either they will say to you f prime of x, Or the question will say y prime, or the question will say dy over dx, or the question will say d over dx, or the question will just put dx. All of this means the same thing: differentiate. In other words, find the derivative. Right, let's actually analyze this question and let us see how we would go about doing such a question. Let's open a new sheet of paper here, and let me just copy down the question. So we have dx of, let's see, we've got x plus 1 here, and then we've got 3x minus 7. Now, according to laws of differentiation, you cannot just find the derivative of x plus 1 and the derivative of 3x minus 7 and multiply them just because the two expressions are multiplied. No. What you have to do is you need to multiply out the brackets. So x times 3x, that's going to give you 3x squared. X times minus 7, that's minus 7x. 1 times 3x, that's positive 3x. 1 times negative 7, that's negative 7. And if you simplify this, you're going to get, this is 3x squared, minus 7x plus 3x, that's going to give us minus 4x minus 7. Now we can find the derivative. When we find the derivative, we get rid of the dx sign. And what we do is we multiply the coefficient with the exponent. So 2 times 3, that's going to give us 6x. We subtract 1 from the exponent, we just remain with x to the power 1. Our exponent here is 1. We multiply the exponent with the coefficient. Negative 1 times 4, that's negative 4x. Subtract 1 from the exponent, that's going to give us 0. Now, the derivative of a constant, the derivative of negative 0, will always be 0. Please take note of that. The derivative of a constant is always 0. Let's see what happens. We're going to remain with 6x minus 4. X to the power 0, we know that's 1. So your final answer is just 6x minus 4. There you are done. Life is great. An important thing that you need to remember, or that you need to make sure that you are quite good at when working with laws of differentiation, is you need to make sure that you understand and you master laws of exponents. I cannot stress this enough. Make sure that you master your laws of exponents, and once you've mastered laws of exponents, only then will you be able to succeed in answering questions pertaining to calculus. If you need a revision or refresher on laws of exponents, on the channel I've got a complete course on grade 11 exponents and surds. Please check it out and make sure that you familiarize yourself with exponents, because it really helps when looking not only at calculus but also at functions. Perfect. Let's move on to the next question. Here we have another question where it says we need to find the derivative of open bracket 1 plus square root of x, close bracket squared. Let's go to the writing pad and see how we would go about doing this. So we have got dx into 1 plus the square root of x squared. Once again, just like in the previous example, I need to multiply out the brackets first. So I'm going to say dx into, the exponent of 2 means I need to have 2 of the same brackets. Like that. From here, let me multiply out the brackets. So 1 times 1, that's 1. 1 times the square root of x, that's the square root of x. Square root of x times 1, that's the square root of x. Square root of x times square root of x, that's going to give us x. And when we simplify this, this is going to give us 1 plus square root of x plus square root of x. If you remember from exponents and surds, that's going to give us 2 square root of x plus x. What I'd like to do is I'd like to write this in exponential form. I'd like to change the surd into exponential form. So this is going to be 2x to the power half plus x. Now we can use our power rule. The derivative of 1, that is 0. Multiply exponent with coefficient. 2 times a half, that's going to give us just 1, x. Subtract 1 from the exponent, this is negative a half. X has an exponent of 1 here. Multiply exponent with coefficient, that's just going to give us 1. Subtract 1 from exponent, this is x to the power 0. Let's simplify this. I'm going to have x to the power minus a half plus 1. What you always want to do is make sure that you write your answers with positive exponents. And to make this the case, I'm going to put this as 1 over x to the power a half. If you can remember, when you have a denominator with the negative exponent, make it the numerator to make the exponent positive, and vice versa. Plus 1. Now when you get to this point, exponent of a half is the same as the square root. So I can write this as 1 over the square root of x plus 1. Then there we are, this is my derivative. Brilliant. I hope that this makes sense to you guys. I hope you understand it and that you're getting the gist of what the laws of differentiation is all about. Right, let's move on and look at another example. Okay, we have another example here. Now, if you want to, take down this example, think about it, and think about how you would go about solving such a question, because this is a common problem that learners are facing, having to convert surds into exponents and then finding the derivative from that. Let's actually see how we would go about doing such. So, let's go to our writing pad, and let's copy down this question. Yeah, okay, still have some room. The question says we have got the dx. Let me put this as a big bracket. This is minus 6 over the 4th root of x to the power 5 plus 2 cube root of x plus pi squared. Okay, the first thing you want to do is write all of the surds in exponential form. So because we're not yet finding the derivative, keep the dx there. This is minus 6 over x to the power 5 over 4 plus 2x to the power 1 over 3 plus pi squared. Now what we can do is we could say, okay, let's take this x to the 5 over 4 to the top. Because you always want to make sure that your surds are at the top. Your surds are numerators. Negative 6 x to the power 5 over 4 plus 2x to the power 1 over 3 plus pi squared. Now that we've got the setup, we can actually find our derivative. So, multiply exponent with coefficient. Let's see. 5 over 4 multiply by negative 6. Let's see. 2 goes in there twice. 2 goes in there 3 times. We've got negative 15 over 2. So, negative 15 over 2x. Subtract 1 from the exponent. 5 over 4 minus 1, that's going to give us 1 over 4. Plus, multiply exponent with coefficient, that's going to give us 2 over 3 x. Subtract 1 from a coefficient. You're going to get negative 2 over 3. Now the pi is very interesting because a lot of learners get confused when they see pi. They think, okay, what do I do with the pi? Well, remember pi is a constant, not a variable. So you cannot say we multiply exponent by coefficient and subtract 1. No, pi is a constant. The derivative of a constant is 0. There we are. Let's continue on the next page. So now that I have my derivative, what I can do is I can put it back in surd form and then write my answers with positive exponents. X to the power 1 over 2, that's the 4th root of x. I'm going to take negative 2 over 3 to the bottom so that it becomes a positive exponent. So this is 3x to the power 2 over 3. And if I want to write this in surd form, this is negative 15, 4th root of x, divided by 2 plus 2 over 3 cube root of x squared. So just a hint if you're getting confused about converting between surd form and exponential form. If I've got x to the power, let's say a over b, what you do is you take your denominator and put it on top of your radical sign, then you take the numerator as it is as part of the exponent of the base. Brilliant. I hope that this makes sense to you guys. Let's actually move on and look at, I believe it's the last question for this section. Right, there we are. This one is quite straightforward. We need to find the derivative of 1 over 4x to the power 4 plus 2x to the power half. Let's actually quickly do this one. It's not going to take much time. It's not supposed to take much time. Let's scroll down and get some room here. So the question is asking us to find d over dx of 1 over 4 x to the power 4 plus 2x to the power 1 over 2. Once again, in this case, if you notice, we've got positive exponents. We don't have surds, so we don't need to worry about anything. We can go ahead and use the power rule. In other words, we take the 4 multiplied with the coefficient. So 1 over 4 times 4, that's just 1. Subtract 1 from the exponent, this is 3. Multiply exponent with coefficient, that's going to give me 2 times a half, that's just 1, so x, subtract 1 here, that's minus 1 over 2. We've got a negative exponent, let's make it positive. So this is going to be x cubed plus 1 over x to the power positive a half. We need to write it in in surd form. So this is going to be x to the power 3 plus 1 over the square root of x, and this is our final answer. Life is great. Let's move on to the next section here, which is the equation of the tangent. Now, a tangent, as we've learned, is a straight line that touches not only a circle, but a curve at only one point. Now, it's a straight line implying y equals mx plus c. It has a gradient, it has a y-intercept. Right, as we've said, since it is a straight line, the general equation is y equals mx plus c. Now, to get the equation of the tangent, if you're familiar with this equation from analytical geometry, we could still use it here, where we say y minus y1 equals m into x minus x1. Right, so the first thing that we need to do when finding the tangent, the equation of the tangent is, if there's no y value which is provided to you, substitute the given x value into the equation of the curve to get y. Now what we need is we need an x value, we need a y value, and we need a gradient. That's what we need for the equation of the tangent. So if there's no y value but there's an x value, substitute x into the original equation to get y. This is something you're familiar with. Now, if we want to get the gradient, we need to find the first derivative. Now, there's a reason why I put first into this section. You will understand as we go along later on that it's not just, you don't find the derivative just once. There are cases where you can find the derivative more than once. So, we need to substitute the x value into the equation of the derivative. This is going to give us the gradient. And from there, we need to use the equation of a straight line to determine the equation of the tangent. A lot has been said. Let's look at some questions. So, the first question says we need to find the equation of the tangent to f of x equals x squared minus 3x plus 4 at x is equals to 2. So, let's go to the writing pattern. Let's actually have a look at this. We are looking at the curve of f of x, f of x is equals to x squared minus 3x plus 4. And we are looking where x is equals to minus 2. Now notice we don't have a y value. That means we need to take this x value, substitute it back into the original equation to get a y value. So f of minus 2, this is going to be minus 2 squared minus 3 into minus 2 plus 4. And this is going to give me 4 plus 6 plus 4, which is going to give me 14. So the coordinate that I have here is -2 and 14. I've got x, I've got y. Now I need to find my gradient. To get the gradient, we need to find the derivative. Now, if we look at the original equation, we need to multiply exponent with coefficient. That's going to give us 2x, subtract 1 from exponent. Our exponent is 1 here. Multiply exponent by coefficient, we get -3. Now let's substitute x is equals to 2 to get the gradient. X is equals to -2, sorry. That's the x value that we're working with. This is 2 into -2 minus 3, which is actually going to give you -4 minus 3, that gives us -7. Now we can actually use the equation of the straight line. Let me just do it on the side here. So we're going to use y minus y1 equals to m into x minus x1. So y minus y1, that's 14, is equals to your gradient is -7 into x minus -2. You're going to get y minus 14 is equals to -7x. Whoops, before I do that, let me simplify this. -7x plus 2. Now y minus 14 will be equals to -7x. Then -7 times 2, that's -14. -14 and -14 will cancel out. You remain with y is equals to -7x. This is your equation of the tangent. Brilliant. Life is great. I hope you guys are understanding it and that you find it useful. Now, let's move on to the next question. For the next question, we're supposed to find the equation of the tangent to h of x is equals to -1 over x at x is equals to 3. Now, once again, here's what we're supposed to do. We are given this, which is a curve, a hyperbola to be specific, and we need to find the equation at x is equals to 3. So what we need to do is, let's go to our writing pad first. Let's copy down our question. H of x is equals to, we've got -1 over x here. And we're getting this where x is equals to 3. Let's first find y. We substitute x into the original equation to get y. Our y is -1 over 3. Brilliant. We've got the coordinates 3 and -1 over 3. Now we need to find the gradient. First, we need to find the derivative. So h prime of x is equals to, first of all, before we do this, let's actually take our variable from the denominator to the numerator. We've got -x to the power -1. Then h prime of x, multiply exponent by coefficient, that's going to be +1, subtract 1 from exponent, that's -2. In other words, we've got 1 over x squared. Now, h prime of 3, this is going to be 1 over 3 squared, which will give you 1 over 9. Brilliant. Now that we have x and y and the gradient, let's find the tangent. So y minus y1 is equals to m into x minus x1. Y minus -1 over 3 is equals to 1 over 9 into x minus 3. This will give us y plus 1 over 3 is equals to 1 over 9x, then 1 over 9 times -3, that's -1 over 3. Y is going to be equals to 1 over 9x minus 1 over 3 minus 1 over 3, which will give you 1 over 9x minus 2 over 3, and that's our equation of the tangent. Brilliant. I hope that this makes sense to you guys, and I hope that life is still great. And I hope that you're following along and that you're taking note of whatever issues that you might have experienced, whatever mistakes that you've made. If you have any questions on what we're doing here, or if you feel like for some reason there's something that you're missing, please take note that the comments have been disabled. You guys probably saw that. But if you have any questions or you feel like you need to further communicate and query, you can drop us an email on live@brainshift.co.za. So again, that's live, Live, at brainshift.co.za. Without any further waste of time, let's continue to the next section. Now we talk about the cubic function. And the cubic function, as you might be familiar with the equation, it's ax cubed plus bx squared plus cx plus d. And what we need to know is the cubic function has the following properties. It has x-intercepts. It might have one x-intercept, it might have three x-intercepts, or it might have two x-intercepts. There's one y-intercept. There's the stationary points or the turning points, where we can have one stationary point or two stationary points. Lastly, there's the point of inflection. Now, we're almost out of time, so let's quickly just run through how to determine each of these. Let's, of course, start with the x-intercepts. So let me just put it down here, the cubic function. So, if we have an equation, y is equals to ax cubed plus bx squared plus cx plus d. We need to find the x-intercepts of this equation. Of course, we need to let y equals to 0. But then what we need to do is we need to use synthetic division or division by inspection or long division in order for us to be able to solve for x. If you don't know how to do that, I've got a video on each of the specific sections explaining how to do it. But let's just look at a simple example. If we've got, let's say, y is equals to x cubed minus, let's say, 5x squared plus 4x, and you want to find your x-intercepts. So, of course, you need to let y be 0. Then you've got x cubed minus 5x squared plus 4x. In this particular example, long division is not necessary because all you can do is you can take out x is a common factor. Then you remain with x squared minus 5x plus 4. Then from here, you can further factorize it. So 0 is equals to x into, we've got here x minus 4, and there's x minus 1. When you have it like this, your x-intercept would be x is equals to 0, x is equals to 4, x is equals to 1. You've got 3 x-intercepts in this case. Life is great. I mentioned to you that you can also have one x-intercept. An example of that would be if I've got y is equals to x cubed minus 1. To solve for x, I need to let y equals to 0. Then I've got x cubed minus 1. Then you take this and you transpose it over. You're going to have 1 is equals to x cubed. Find the cube root here. Find the cube root there. You get x is equals to 1. We've got only one x-intercept in this case. Now, just to talk about the general shape of each of these cases, if we've got 3 x-intercepts, your graph is expected to look something like this, where you've got your first intercept there, your second x-intercept there, your third x-intercept there. If we've got only one x-intercept, then what will happen is your graph will have a slightly funny shape, but what's going to happen is your graph would look something like this. Whoops, something like this, where you've got your x-intercept right there. We can also have a scenario where we've got 2 x-intercepts. Now, such a case would be, let's say if we've got x minus 3 all squared into x plus 1. In this case, if we let y be equals to 0, this is going to be x minus 3 into x minus 3 into x plus 1. Now, we are going to say x is equals to 3 or x is equals to negative 1. Please take note, there's no point in saying x is equals to 3 or x is equals to 3 since it's the same thing. Here we are, we actually have 2 x-intercepts, and for such a graph, usually what would happen is the x is equals to 3 or the x-intercept that's repeating becomes a turning point. So you've got something like that, where your x is equals to 3 is there, and you've got the x is equals to 1. Of course, my shape is a bit off now, but you get the general idea. If two x-intercepts are the same, there is a stationary point or there is a turning point at that specific x-intercept. Right. Let's move on. We are a little bit short on time. Nevertheless, we've already spoken about the x-intercepts. For the y-intercept will always be the constant in an equation. So if I've got y is equals to x cubed minus 6x squared plus 4x plus 5. Positive 5 is our constant, and therefore y is equals to 5 would be our y-intercept. Right. We've got stationary points or turning points. To get the stationary points, we need to find the first derivative and set it equals to 0. Solve for x. Once we have x, we need to substitute x back into the original equation to get the corresponding y values. Please take note, you do not substitute x into the first derivative. You substitute x back into the original equation, the equation of the cubic function, because that's where we are going to get y from. I hope that this makes sense. Now we also have the so-called point of inflection. And to get the point of inflection, it's very similar to how you would do your your stationary points, except that here you need to find the second derivative and set it equals to 0. What is the second derivative? This is the derivative of the derivative. You set that equals to 0 and solve for x. Once you have x, you substitute it into the original equation to get the corresponding y value. I hope that this makes sense to you guys. Our last section for today, unfortunately due to time constraints, is the application of calculus, optimization, and rates of change. As we've mentioned, we can apply calculus to many different fields: finance, economics, science, and many other branches, even statistics. Now, in order to find maximum or minimum of a given scenario, you will see the keywords. You need to pay attention to the keywords: maximum, minimum, highest, lowest. If a question states maximum or minimum, you must find your first derivative and set it equals to 0. This is similar to finding the stationary points of your cubic function. Solve for the unknown variable. Then in certain cases, you need to substitute the unknown variable back into the equation to get the corresponding y value. Right. One last part. When we are looking at the application of calculus, you need to be in a position to express a problem in terms of an equation. If there's two variables, you need to eliminate one variable and use simultaneous equations. You need to use your unknown variable by setting f prime equals to 0. You need to solve for the unknown variable by setting f prime equals to 0. For those of you that subscribed and got access to the channel through the subscription that's been going around in our poster, i.e. for those of you who subscribed via live.brainshift.co.za, I'm actually going to email you after the session within the next 24 hours. I'm going to email all of the notes that we've been busy with here. You will receive them, including the handwritten notes. I'm also going to include an example pack of the cubic function, how to solve the cubic function, as well as some examples and questions on optimization. I would love to cover optimization and more of the cubic function with you guys, but unfortunately we are only allocated a certain amount of time and resources to do the broadcast, and as a result we're going to have to terminate it here. I thank you guys so much for subscribing. I thank you so much for watching. If you've made it to this far, well done. I hope that you find it productive. I hope that you enjoyed this, that it was really worth your time. And once again, as I've said, if you have any questions, if you have any comments, we would appreciate your feedback. Please email us on live@brainshift.co.za. Once again, live, L-I-V-E, @brainshift.co.za. We would really appreciate your feedback, and please do take note that next week we have another session for grade 11s. That's the sine, cosine, and area rule. If you're interested in that, please do sign up and join us for yet another experience and another wonderful event of learning. Thank you guys for joining. Until we meet again, bye-bye.